Hence, there is less hurry and consequently closer attention to detail. Insulator quality begins on the tracing paper. Now, this suspension insulator is an original Pinco design, the work of men skilled in ceramic craftsmanship and schooled in all the problems of fine insulation. Pinco designs require the finest of raw materials. We import our ball clay from Cornwall in England, our china clay from Devonshire. Now, this material is flint from Pennsylvania, and this bin contains Canadian feldspar, the finest grade of quartz rock. Carefully weighed in the correct proportions, the flint and feldspar are ground together in pebble mills. They're so called because they use Japanese grinding pebbles to refine the grain structure. The flint and feldspar discharged through pipes is mixed with the clay. The ball clay, passing through these lawning machines made up of oscillating screens to remove all impurities, the slip passes through the field of a powerful electromagnet to remove metallic particles and is then pumped into filter presses, canvas bags pressed between metal. To prepare the clay for actual insulator production, these discs are placed in a pug mill in which circular knives refine the clay texture. The clay is extruded in various shapes and sizes depending on the insulator for which it is used. All insulators except extruded types are formed in plaster Paris molds. Here the Pinco suspension unit is plunged by a machine operated by skilled workmen. Tamped into this mold with this simple tool, the clay is ready for the plunger. The plunger completes the forming operation. "24 hours later, the suspension disc can be removed. To hand-shape clay properly requires years of experience. for the finishing. Pinco originated and patented this suspension disc can be handled for the finishing operation. Every attention is given to perfect shape and symmetry. Inspection at all stages of the manufacturing process eliminates the possibility of defects. Precision is assured at all stages by the use of standard gauges. For finishing high voltage tin types made in one piece, step in the preparation of the clay, and tamping is the next, both of which are followed by the plunging operation of producing the first one-piece high-voltage tin-type insulators by plastic process. Hand molding is which brings the clay up in this high hat shape. A split mold is added to the lower mold and passed down a conveyor to the second machine. A tapered steel rim holds the mold firmly, and a dash of oil prevents the clay from sticking the heated plunger as it completes the formation of the unit. And now for another Pinco development. Our patented threading process. The thread is rolled into the previously formed hole, shaping the thread with accurate pitch and taper. The completely formed unit, number 1125, rolls down the conveyor ready for the finishing. We have developed automatic machines. This one performs 3 operations simultaneously while the careful fingers of the craftsmen lend their touch of artistry to the job. Tie wire groove must be cut accurately. This precision machine does the work with ease. These automatic machines ensure perfect adherence to the design so carefully worked out by our specialized designers. Dried columns of clay are turned on automatic lathes into transformer parts. curved hole with a straight drill by removing the guide strain through an arc. Some larger shapes made wholly by hand on potter's wheels by a process called jiggering. This process requires considerable handwork, and the operator must be a trained and experienced artisan. Columns of clay direct from the pug mills are formed first by hand and then put into molds. The outer contours of the switch insulator shell are shaped by the mold and the inner surfaces by the hand, guided by a wooden profile. This clay must be worked without introducing distortion or strain lines into the plastic mass. This is a critical operation which we entrust only to employees of long experience. 24 hours after much of the work is performed by hand, like the ancient craft of the woodturner. While profiling machines equipped with a special guide do the rest, this machine drills finishing. All insulators remain in drying rooms for a week to remove all moisture. Glazing begins with a thorough cleaning under compressed air and close inspection for cracks or defects. Even a surface defect means rejection. But this one is okay. And it is dipped into the glaze, which is carefully mixed from the same basic materials as used in the porcelain itself. From the glaze, the insulator goes onto a revolving wheel where a band of porcelain glaze is added. Porcelain sand is sprinkled onto the wet surface to form a rough contact for cementing. In firing, this sand becomes a part of the insulator. A paraffin coat holds the sand in place. Porcelain sand in the pinhole makes a secure anchorage for the pins. And again, another inspection to ensure perfection before the next operation. Glazing of pin-type insulators follows the same routine. Likewise, switch-type insulators. Special machines have been developed for testing smaller units. This test ensures complete uniformity of glazing and speeds up mass production. Kilns receive the glazed insulators. From above, we see a stream of suspension insulators flowing into the kiln. Encased in sagers to protect them, These insulators receive individual intentions. When sealed, the kilns are fired by men skilled in keeping fires at an even temperature. Each firing operation is recorded on a special time clock, and a pyrometer gives a further temperature check. And vitreous rings, which shrink in proportion to the temperature, are tested at regular intervals. These are cooled in water, and when cool, are then measured in a gauge and a shrinkage recorded. These rings are preserved. And the history of each kiln is thus recorded and kept. Cones which melt at After the 80-hour period required for firing and cooling of the kiln, the insulators are removed and loaded onto trucks. Now these insulators are ready for testing.
Suspension insulators undergo a very rigid inspection. This flashover is only one of the many tests they receive. Another inspection follows. The same treatment is given all our insulators. These one-piece tin-type insulators are first inspected and then subjected to an even greater test. The over-voltage test. Hardware designed by our own technicians is made to our order. All parts are carefully inspected before use. Metal pins pass under the scrutinizing eye of reliable inspectors. Any defective parts are rejected. Metal caps undergo the same close inspection and are painted inside. Pins undergo a light process. This Pinco waterproof compound gives protection against temperature changes. The tip is built up with resilient compounds to provide a cushion for thermal and mechanical stresses. Suspension insulators are assembled on racks and machines by workmen skilled in their trade. Pins are cemented with cement especially developed for the purpose. Steel racks convey the insulators to steam rooms. Steam rooms, the insulators with pins inserted, return to the assembly room for capping. The parts to be cemented are first dipped in waterproof compound. The caps are cemented on with specially prepared cement. Again, the insulators are ready for the steam racks, which are regulated by thermostatic controls. These charts reveal which are automatically regulated by the mechanism you see just above the door. Upon emerging from the steam rack, the insulators are given a thorough cleaning. Buffing wheels restore their clean, glossy surface, and any spots missed are touched up by hand. Suspension insulators into springs are specially designed together and then locked automatically. Special crates are built to meet conditions. Next, the insulators are tested for strength. This machine exerts a pull much greater than the insulator is designed to bear in actual use. Will do over long periods. Type insulators are assembled in a specially designed jig to ensure perfect fit, accurate alignment of parts, and complete interchangeability of insulators of the same type. A final flashover test is given to ensure the insulator meets the requirements. And then a thorough inspection. Insulators are built to stand myriad hardships, whether it be for use on a pole in the desert, or the far northern waste, or in the center of a busy city. The insulator must qualify by test before it leaves our plant. This mechanical hammer test tells us what impact they will withstand. The mechanical and electrical test tells us what sudden weight of sleet or ice it will bear without breaking, while it guards the transmission line. The cantilever test tells us just what resistance it has to lateral stress, which may come from wind or water or impact. The torsion test tells us just this thing, it breaks. Strung for months in all kinds of weather under heavy weight tell us that Pinco product resistance to sudden changes of weather is ascertained by the thermal test. From boiling water to ice water, this test tells us that the sub-zero of early morning can merge into sunlight filled with quick warming rays
without a cracked insulator. But ice water is not close enough to the bottom of the thermometer. In this ice box, the insulator requires a soda froth. The chart says 40 below. Design and quality go together. In this design test, we find out what the insulator will do under varying conditions. In dry weather, and with a filmy mantle of rain fluttering down to tax the effectiveness of the insulation. Porosity, diffusion test. Insulators come in contact with all kinds of moisture, oil, water, even acid. They must be perfectly non-porous. Pressure tanks, broken bits of our porcelain are dropped into a solution dye, and after a lapse of time, the pieces are taken out. Pieces are broken with a hammer. No dye has penetrated. Thus assembled and crated, extension insulators flow in a steady stream onto freight cars, going out to fill the heaviest demands of the transmission line. Tested for the purpose in our own laboratory. Christmas brought this boy a rifle, but not a target. Ah, here is one.